All right, Fundamentals of Gas Cutting and Welding, course number D06202, credit 6 PDH is A, but that's by the CED Engineering Company or Continuing Education Development Incorporated, 9 Gray Ridge Form Cut, course Stony Point, New York, 10980. Fundamentals of Gas Cutting and Welding. Gas welding and cutting. Oxy-fuel welding, commonly referred to as oxy-welding, and gas welding is process of joining metals with application for the heat created by gas flow. And the fuel of the gas, commonly acetylene, will be mixed with proper proportion of oxygen in mixture chamber welding torches produced with a very high flame of the 5700 to 5800 degrees Fahrenheit. With the flame, it is possible to bring any with the so-called commercial metals, namely cast iron, steel, copper, aluminum, to a molten state and cause fusion of the two pieces of the like metals of such manner that the point of fusion will very closely approach the strength of the metal fused. The more metal-like nature is added, the union is more even stronger. The original method is called the acetylene welding. Cutting the oxy-fuel process is the opposite of the welding. Oxy-fuel cutting in it with the acetane and oxygen is to preheat the metal with a red hot and then use the pure oxygen to burn away the preheated metal, because the achieved oxidation is only effective for the metals that easily oxidize at this temperature. Such metals are mild steel and low alloy steels. Oxy-fuel cutting can be used when the cut of thickness of 2/8 of an inch up to 12 inches. Traditional oxy-full process used in brazing, fusion, welding, flames, hardening, metal soldering, stress relieving, cutting, and bending. Primary use today are welding, brazing, cutting. The course of the description and basic concepts of the oxy-welding and cutting include what equipment and safety precautions are needed. Your chemistry, acetylene process. The most common fuel with welding acetylene is a two-stage reaction. The first is the primary reaction involved with the acetylene dissociating in the presence of oxygen to produce the heat of the carbon monoxide hydrogen gas. All right, 2 chlorohydrate plus 2 oxygen equal 4 carbon monoxide, and 2 hydroxide plus heat. Your secondary reaction follows with the carbon monoxide hydrogen combined with the oxygen with the carbon dioxide and water vapor. You have your 4 carbon monoxide, 2 hydrogen molecules, and 3 oxygen molecules equals 4 carbon monoxide, carbon dioxide, and 2 water molecules plus the heat. When you combine equations 1 and 2, you will notice that the 5 parts of oxygen is necessary to consume the 2 parts of acetylene. All right, 2 carbonide hydrogen molecules with the 5 oxygen molecules equal 4 carbon dioxide, 4 carbon dioxide with 2 water molecules plus the heat. One can say that about 2.5 oxygen is necessary to achieve the completion of the combustion of the acetylene and operation of one part of the oxygen is supplied with the torch, and the remaining of the 1.5 is obtained with the surrounding it, the air atmosphere secondary reaction. When the secondary reaction does not burn all the reactants from the primary reaction, the welding process produces large amounts of carbon monoxide, if it often does, and it often does because of the need of the supplemental oxygen from the atmosphere. The acetylene oxygen can be used inside the pipes and structures subject to the oxygen depletion with the gas welding by variety of the relatively amounts of acetylene. Oxygen's welder can produce a different flame atmosphere temperature as he requires. Oxygen welding gases. Commercial fuel gases have commonly property that will require oxygen to support the combustion. A suitable welding operation of fuel gas will burn with the oxygen must have the following: high flame temperature, high rate of flame propagation, adequate heat content, minimum chemical reaction, flame base, and filler metals. Alright, and among the commercial availability of fuel gas and propane, liquid petroleum gas, or LPG, natural gas, propylene, and hydrogen, and MAP gas, acetylene must closely meet all the above requirements. Acetylene and hydrocarbon, just a propane, methane, virtually all the components of the make the gasoline and fuel oils. However, it does those hydrocarbons in a way of the molecule is made with the 2 carbon atoms, 2 hydrogen atoms, and the carbon atoms are joined when the chemicalist called the triple bond. The acetylene reaches the kindling temperature, the bond breaks and releases the energy. And the hydrocarbon, the breaking of the bonds between the carbon atoms, and they absorb the energy. The triple bond is a reason for the acetylene and oxygen are mixed and initiated. The flame can reach up to temperatures of 5700 to 6300, highest temperature among all the gas fuels. The other property of excilatane, which used and remember the excilatane air mixture can be initiated with they contain 2.5% excilatane, 80% excilatane mixture of methane, principal component of the natural gas area, and flammable, which they contain at least 5% methane, no more than 15% methane. Kindle temperature is the lowest temperature at which the substance bursts into flame. The other two gases suitable for welding cutting are MAP and hydrogen. MAP is a registered product of the Dow Chemical Company. Is a liquefied petroleum gas mixed with methanol, excilatane, propadiene, or acetylene and propane. It has a storage of shipping characteristics of liquid petroleum gas and has a heat value of less than acetylene because it's shipped in small containers for sale, the retail sale used by the hobbyists. Methanol, acetylene, propadiene gases can be used with a high pressure of acetylene, sometimes 40 to 50 psi, with a higher volume oxygen cutting torches which can cut up to 12 inches of thick steel. The methanol, acetylene, propadiene gas leak is easy to identify because of the particular terrible odor. Hydrogen produces low temperature flame and best for aluminum. Hydrogen flame is non-luminous, commonly used for underwater welding. Can be used with a high pressure, you can be used at high pressure than acetylene. Gases suitable for cutting but not welding: propane, methane, and liquid petroleum gas. However, hydrogen carbon gas such as propane, butane, city gas, and natural gas are not suitable for the welding of various metals due to the oxidization characteristic. Although propane has a very high number of BTUs per cubic feet in the outer cone, it does not burn as the hot acetylene inner cone. They're not very useful welding operations. However, the right torch injector style propane can be make a faster and cleaner cut is much more useful heating of the bending of the application than acetylene. Some instances, non-ferrous and ferrous metals can be brazed, welded, which can take an adjustment flare to the use of the flux. Alright, the characteristic of acetylene hydrocarbon burns with the two-stage primary combustion zone, or the cone flame, and the secondary combustion zone, the envelope flame. Acetylene and the colorless gas very distinct nauseating odor with a higher combustible gas mixed with oxygen. Acetylene gas is formed in a mixture of calcium carbonide, water, and is composed of carbon, hydrogen, having a chemical formula of C2H2. Natural flame to temperature 5,420 degrees Fahrenheit at the end of the inner cone. This could be increased to the maximum about 5,800 degrees, increasing the oxygen quantity through the torch exercising flame. Combustible intensity of the 12,700 BTU square second of square foot in the cone area, and 1-to-1 mixture of acetylene and oxygen through the torch. The net heat value is 1,433 BTU per cubic feet. Advantages of acetylene pressure: does not require electricity. The equipment is portable, easy transport. Welder is considerably control over the rate of the heating and input, the temperature of the welding zone, oxidizing, reducing potential in welding atmosphere. Acetylene process is ideally suited for the welding into sheets and tubes and small diameter pipe. It's used for repair work, maintenance, and body shops. Similar metals can be easily joined, and can be used with the preheating cutting metal with the case for the hardening and solidifying and annealing. Limitations of acetylene. Acetylene becomes extremely dangerous if it is above 15 pounds of pressure. Pure acetylene is self-explosive and stored with free state under the pressure of 29.4 pounds per square inch. The process is typically slower than electrical arc welding process. We'll learn more about acetylene process equipment for the course. This course is divided into 4 sections. Section 1, acetylene apparatus. Section 2, oxyacetylene welding. Section 3, oxyacetylene cutting. Section 4, oxyacetylene safety precautions, including case study and extra terminology, which we probably won't read. Section 1, acetylene apparatuses.